first case that we're going to look at is strong acid and strong base. So here is my endpoint equivalent point, Miss dah tulis. Okay, so sebenarnya dua-dua ni sama je for case strong acid, strong base. Cuma beza dia dekat sini analyte Miss adalah HCl. This one is sodium hydroxide. So kalau ni mestilah vice versa lah. Okay, so first we're gonna look at for your strong acid, strong base. So at the beginning of titration, so maknanya at the beginning of titration, dalam conical flask ni Miss hanya ada HCl. Sodium hydroxide is not yet added. So HCl is a strong acid. So when it is a strong acid, okay, strong acid, HCl equals, dia akan fully dissociate to form H plus equals and Cl minus equals. Okay, so maknanya dia adalah strong acid, dia fully dissociate. So here we have high concentration of H plus. So bila high concentration of H plus, maknanya kita macam strong acid kan. So pH dia akan jadi low lah. Sebab itulah at the start pH has a low value about 1 to 2. Okay, and then just before the equivalent point, we know that equivalent point kita adalah 7 dekat sini kan. Okay, now it's added slowly to HCl and the pH will increase slowly. So kenapa pH increases slowly? Sebab at the start pH dia low. Dia nak capai 7, mestilah dia kena pH increase. Takkanlah pH decrease. Kalau pH decrease, nanti pH kita jadi negative value kat bawah ni macam tu. Okay. And then, once we have reached equivalent point, when one more drop of NaO is added, the pH will change sharply from 3 to 11. Sebab equivalent, kalau equivalent point, it means that 1 mole NaO, 1 mole HCl is completely reacted lah. So, what it mean that, so kat sini apa yang dimaksudkan is actually, NaO ni akan jadi excess reactant kita. So, HCl is completely reacted kan. So, NaO ni yang ada banyak sikit. NaO is our excess. So, bila NaO is excess, NaO is the base. So, that's why the pH will change sharply from 3 until 11. And then, at the equivalent point, remember the pH is the pH of the salt solution, which we have learned the salt hydrolysis, strong acid, strong base, neutral salt. So, dekat sini dia pun sama juga lah equivalent point 7 because it is our neutral salt. And then, after the equivalent point, the pH rises slowly as now in excess. Sebab HCl dalam ni completely reacted kan. So kita tambah-tambah lagi NaO. So apa yang ada dalam ni actually is NaO dengan NaO je lah. HCl dah tak ada dah. Ada NaO, ada NaCl, ada H2O. So kenapa pH rises slowly? Sebab we have NaO is a strong base, fully dissociate to form Na plus OH minus equals. So again, strong base, so high complete dissociate, high concentration of OH minus, strong base, pH dia akan tinggi lah. So that's why kita tengok pH dia is high. Okay, so what's the difference here? Apa beza yang atas dengan bawah ni? Bawah ni kita start dengan NaO. So that's why at the beginning of titration, pH has a high value. Sebab dalam case ni, is that in the conical flask, we have our sodium hydroxide. So yang ini. So bila dia ada banyak base dalam ni, hanya ada our base. So it means the high concentration of OH minus. So sebab itulah pH dia starting dia dalam kes ni pH dia yang tinggi. Sebab dalam ni ada base je. Tadi awal-awal ni beginning ni hanya ada HCl. So pH dia kena low lah. Tapi kalau dalam dia adalah base strong one pula tu. So pH dia is high. Okay, so again, so bila dia dah akan added slowly. Once dah reach equivalent point, dah akan change sharply lah. Okay, dah akan change sharply to 3. So kiranya kenapa dia decrease? Sebab what we have in excess right now is our acid base. And then maksudlah pH decreases slowly. Sebab kalau pH is low, kalau acidic is high, the pH would be low. Okay, that is for the case of strong acid, strong base. Next, we'll look at for the case strong acid and weak base. So dalam case ni, our analyte ataupun the solution in the conical flask is our ammonia. Okay, so at the beginning of the titration, pH has a high value. High value ni sebab dia adalah is a base. So base mestilah high sebab more than 7. But then dia adalah weak base. So weak base dia akan partially dissociate. So what will happen adalah NH3 aqueous plus dengan H2O. H2O liquid. Okay, so base ni dia akan accept H plus from our H2O. So dia akan jadi NH4 plus aqueous tambah OH minus aqueous. Okay, so it is a weak base. So sepatutnya the concentration of OH minus is not that great lah. So that's why kalau contohnya tadi kalau kamu tengok strong base starting dia adalah 13. Tapi ni kenapa 11? Sebab our ammonia is a weak base. So concentration it is partially dissociate. Concentration of OH minus decrease. Okay, and then just before the equivalent point, HCl is added slowly. So once our acid dengan base ni completely reacted, sekarang ni dalam conical flask kita ni lah kira kita punya limiting reactant kan. When we add some more of the HCl, the pH akan pergi kepada, the pH will increase but acid is the pH will decrease but acid bila dah have excess acid, pH will be lesser than 7. Susah lah kalau okay. And then equivalent point kita is, okay, for the case of strong acid weak base dia adalah pH 5. Dia adalah acidic salt. But remember strong acid weak base akan form acidic salt. Okay, so acidic salt dia is not 7, salt dia bukan 7, bukan 9, dia mestilah lesser than 7, which is 5 lah dalam case ni. Okay, so when one more drop of HCl, yang ni mesti kat sini lah kan. So dia adalah acidic salt. So sekarang ni the beyond the equivalent point, maksud dia bila dah 1 mole completely react dengan 1 mole NH3, have excess HCl. And then the pH will decrease slowly as there are excess HCl added. Okay, kalau HCl is a weak acid, is a strong acid, it will fully dissociate. So bila this fully dissociate, it will have a high concentration of H+. So that's why kita tengok kalau strong acid, kat sini pH dia kira low lah. So that's why dekat sini kita tengok bila banyak acid tu, pH dia is 1 because it's a strong acid. The last case, the last titration curve that we're going to look at is weak acid and strong base. So what we have here is my weak acid as an analyte and strong base as our titrate. Okay, so at the beginning of titration, pH is about 2.8 because our ethanoic acid is a weak acid. Okay, so when it is a weak acid, dia partially dissociate. So yang ni Miss malas nak buat dengan water. Aqueous, so partially dissociate, equilibrium arrow. So akan form CH3, COO minus, aqueous plus, H plus, aqueous. Okay, so that is what we have lah. So because it's a weak acid, partially dissociate, the concentration of H plus is not that high. Consider kalau dia adalah strong lah. So that's why lah pH tu dia tinggi sikit. Kalau contohnya strong acid kan kat sini kita nampak dia pH dia 1 kan. Okay. So and then just before the equivalent point. Okay, dalam case ni strong base, equivalent point dia 9. So it's a basic salt. So dia punya pH will be higher than 7. Okay, so dekat sini again bila kita dah after equivalent point ni, after the equivalent point, so kiranya dalam case ni, our acid is our limiting, now ni yang in excess. So that's why lah pH tu dia akan ikut now sebab dia ni in excess. Okay, so the pH at the equivalent point is the pH of the salt solution, pH 9 basic salt. And after the equivalent point, the pH again rises slowly as there in excess now sebab now is our strong base. So dia fully dissociate. So when it's fully dissociated, apa ni? So maknanya the concentration of OH minus is high. Concentration of OH minus is high. So that's why lah pH dia kita tengok ni dekat-dekat dengan 13. Kalau tadi kita tengok kan kat sini weak base ni pH dia bawah sikit. So ada relate balik dengan strong acid weak base. So make sure lah tulis ni kat mana-mana juga. So sometimes lupa apa maksud pH tinggi, pH rendah ni Miss tak ingat Miss pun kadang-kadang tak ingat tak. So kena tulis. Okay, so that's the end of our titration curve. Okay, the last part of 7.2. Tengok dia sekejap je pun 7.2 ni. One day kita boleh habiskan. Okay, is indicator. Sebab indicator is used to detect the end point of titration. So kalau kita punya eksperimen, kita mostly guna phenolphthalein lah, from colourless to pale pink. Sebenarnya pale pink. Okay, so sebenarnya indicator is not only phenolphthalein, banyak. We have a lot of indicator here. Ada banyak. But actually how to choose which indicator is used for which experiment is actually you have to look at your pH range. Okay, so the pH range tu, it must be on the steep line, which means we're gonna look at our endpoint lah. Ni, choose an indicator which the endpoint lies on the steep part. So kita tengok kena depends on endpoint. So this choice will ensure that the pH at the equivalent point will fall within the range over which the indicator changes color. Okay, so yang ini is a summary. So sekejap je yang ini. Titration, as we can see, kena ingat ni endpoint, pH range. Kalau equivalent point, kena ingat for titration curve. And here is our indicator. So for strong acid, strong base, any indicator can do. So range dia besar. It's between 3 until 11. So kalau 3 until 7 strong acid yang ini, kita kena tengok lah berdasarkan indikator apa yang dia bagi. Okay, so for example, kita tengok ni. Choose the suitable indicator based on the table given. Okay, so yang ini Miss akan buat jadi soalan Google Form lah. So once kamu tengok Google Form, nanti boleh. Okay, so what I'm gonna do, first kalau macam mana nak choose is that, first, kalau contohnya dia bagi dekat kamu, they have given you the solution and they give you your indicator. So what is the step to choose which indicator to which solution? First we're gonna number 1, determine the type of titration lah. The type of titration. So, apa maksud type of titration ni, Miss? So, it's between strong acid, strong base, strong acid, weak base, weak acid, strong base. Okay, so second one is that, once you know this one, so, kita akan tahu, so that we can find the endpoint. So bila kita dah tahu endpoint, so endpoint is based on the type of titration, barulah last kali kita boleh choose the indicator. So bukan satu je indicator boleh jadi. Tengoklah, kalau ada dua, kalau ada tiga. Look based on the question. So nanti Miss akan bagi Google Form juga based for the question of indicator dengan a bit of titration curve.